Hello students, welcome to Young Cubs. Today we are doing the chapter electricity and this is the second session, or you can say part 2 of this chapter. Last lecture we had just begun to understand a few words. I couldn't call them as key terms or key terminologies, but just a few simple words that would be occurring each time you go through your textbook. Today, we will actually do the key terms. These key terms will keep repeating in your text, and you will have to use these key terms in your definitions and whenever you write your answers. Okay, so the first one we have is a conductor. What is a conductor, children? It is any material. A conductor is any material. So, any material that allows electricity. That allows electricity to flow through it. Easily. Okay, so what is a conductor? Any material, anything. It could be cloth, it could be plastic, it could be paper, but ideally paper and plastic do not allow electricity to flow through it. But the ones that allow electricity to flow easily through it, what does it allow electricity to flow easily through it mean? That the negative charge easily jumps from one electron to the other easily. The exchanging happens. This jump goes to that one, like we did it yesterday, right? The free electrons move from one electron to the other. So the free jumping or free moving of these electrons easily through a material, and that material is known as a conductor. The examples of conductors are gold, silver, copper, tungsten. Yeah? Tungsten. What is tungsten, children? It is that wire which you see in a bulb. Yes? Okay. On the other hand, what is an insulator? An insulator is any material that does not allow electricity to pass through it. For example, the non-metals. Okay, most of the metals are conductors of electricity. Okay, and most of the non-metals are non-conductors or insulators of electricity, simply because the jumping of electrons don't happen. They are not willing to give out their electrons. They want to accept, but they are not willing to give it out. Okay, so any material that does not allow electricity to flow through it is an insulator or bad conductor of electricity. Examples of the material are wood, plastic, glass. It is not willing to give out its electrons. Okay, rubber, etc. Many more. again, deviating a little from physics to chemistry, you will find all your metals on the left hand side of your periodic table of elements in group 1 and group 2 elements, and then you have the list of transition metals. And you will find your non-metals on extreme right, okay, that is group 2, group 3, so that around after group 5, group 6, okay, group 6, group 7, group 6, group 7 are good insulators. Okay, children? Now, tell what is a cell? A cell is anything that powers an electric circuit. Remember the positive electrode, which is longer, the negative terminal or the negative electrode. So this pair of positive and negative makes one cell. Okay? So let me just write it. So a device that powers electrical circuits is called a cell. Okay, and what did I just explain? A cell has a positive terminal called anode and a negative terminal called negative terminal. I'll just put the sign here, children. You can insert it, called cathode. All right? Okay. Battery. What is a battery? This is one cell. Correct, children? Okay. And battery may be a series of cells in a circuit. The whole thing is known as a battery. So what is a battery? More than one cell in a circuit is called a battery. So more than one cell in a circuit is called a battery. Yes, children, easy. And now, what is the meaning of output? Output is nothing but the electric current that flows out of a device. What does that mean? What does out of the device mean? So, if there is an electric current flowing through a wire and I attach a bulb or a buzzer or for that matter, there's an oven in the house or the refrigerator. Okay, so the electricity, when it flows through the wire and it reaches the mixer grinder, and this mixer grinder starts working, okay, that is known as the output. It starts powering, or it gives them the electric current, and that electric current is clearly showing that that my mixer grinder or my oven or my refrigerator or my bulb is lit up or has shown the effect of electricity. It is known as the output. So how will we define it? Output refers to the electric current that flows out of a device, okay, in a circuit. Next, we come to the negative pole. Negative pole, remember, the shorter one. This one is the negative pole, okay, or the negative terminal, or the negative electrode. Yes, so the electrode from which the electrons emerge. Emerge means comes out. Okay, emerge, because it has to give out the negative, emergence or the negative charge, so that the electron of the first atom of the wire jumps away, or repulsion is created. Okay, so the electrode from which the electrons emerge in the negative terminal is the negative pole and is called the negative pole. It is called the cathode. Yes, important. What is the positive pole? The electrode that receives, it does not emerge a positive charge. Remember, the positive charge is inside the nucleus, not easily transferable. So this one, the positive charge, the longer one, receives electrons, is the positive pole or positive terminal. It is called anode. Yes. Okay, so remember children, positive, negative. Okay, from a wire, the charge moves. These are your electrons touching each other. The charge jumps, okay, all the way around. Okay, these are your atoms. They're quite stuck to each other, children. Okay, the charge runs or jumps all over, and then this terminal receives the charge. Yes. Okay, so that's why it's the positive terminal. Alright. Next comes, what is a circuit? A circuit is a closed path of a wire along with electric components that allows electric current or electric charge. Let me write current. Electric current to flow. Yes, so positive terminal, negative terminal. Okay, when there is a complete loop or a complete circle or a complete pathway formed, this whole thing is called a circuit. So now this circuit will definitely have a battery, it will have wires, it may have a switch also, children. Okay, so if this switch here, if it is open, okay, if it is open for any reason, okay, it is not forming an entire path, so electricity will not form, though it will be known as a circuit only. However, if it is closed, then only this thing will go round about from the negative to the positive and move in a complete loop or a circle. All right, okay, along with its electric components simply means you can add a bulb out here, that's the symbol of bulb, you can add a buzzer or a motor. So the entire thing along with the battery wire, battery or cell, wire, switch, any output device like the bulb or a buzzer, the entire thing will be known as a circuit. Remember, a closed circuit is something when the switch is closed. An open circuit will be something where the switch is open and you don't want electricity to pass through it. Every time, all 24/7, you cannot keep the circuit open, right? Okay. Now, next comes the potential difference. Now, okay. Potential difference is also known as voltage. So, potential difference is nothing. First, I'll explain. Potential difference is nothing but the work done in a unit charge from one electrode to another electrode. So, we know positive electrode, negative electrode. Now this is the wire, correct? So here these are your electrons. Okay, children. So the work done. There is a what is work? Okay, in physics, work is something where a thing is moved from one place to another. The displacement of anything is known as work. So there is a displacement of an electron happening from one atom to the other. Correct? So potential difference is nothing but that work, that displacement work done in moving a unit charge, one single charge. A unit charge means one single charge. So potential difference is defined as the work done in moving a unit charge, okay, from one electrode, and then one electrode will always be cathode, to the other electrode. All right. And what is the unit of potential difference? The unit is volt. Okay, children. Understood what is potential difference? It is the work done between the two electrodes. Next in line is the current. Current is the rate of flow of charge or charges in a unit time. Children, what does the word rate mean? Rate means how fast. Okay, so how fast, that means time is involved. Okay, unit time means 1 second. Okay, so remember, whenever you see the word rate in any of the formulas, remember time will come in the denominator. Okay, flow of charge. Which charge is flowing across a current? The negative charge. So how fast the negative charge or the electron moves across the circuit is called how fast, children. Okay, the electron moves around the circuit is called the current. Okay, so it is the rate of flow of charge in a unit time. It is measured in amperes. Okay, and current is denoted as and denoted by the letter capital I. Okay, children. So current is nothing but I, which is current, Q upon T. I we know, T we know the rate, so the time. What is Q? Q is the charge. The charge is denoted, or the negative, the electrons are denoted by the letter capital Q. Okay. Next comes work. What is work? This is also a kind of measure. So how much work means how much energy is being transferred. So it is the measure of energy transfer that occurs when an object is moved. Remember, children, I had told you in physics, if anything moves, it is considered as work. If you're sitting in one place and maybe memorizing something or reading something, but you're not moving, that means you're doing no work. So, an object is moved over a distance. So, the electrons moving over a distance, okay, is known as the work done by an external force. Okay, if I so if an electron is being pushed across a circuit, okay, then it is the amount of work done. There is some work happening. All right, the force is applied in the direction of the displacement. Now, what does this mean? We understood this much. It is the measure of energy transfer. Energy has to be transferred. Energy has to move. Okay, that occurs when an object is moved. So energy is not visible. Okay, if an object moves, then only we know that the energy has been put into it. Okay, over a distance by an external force. Okay, now what does this mean? The force is applied in the direction of the displacement. So if there is a box out here, okay, if somebody is trying to push it in this direction, the displacement of this box will happen in this direction. So the force applied, okay, is in this direction, correct? So the displacement is also happening is in this direction. So that's when it is known as work. If you're pushing something and it's happening, something is happening in another direction, okay, it is not considered as work. Okay, so the force applied and the direction of the force applied has to be the same. The displacement of the object has to be in the same direction as the force applied. All right, children. Now, what is resistance? Resistance is something, if a metal is not pure. So, if this is a copper wire, okay, it should have only copper electrons, children. But if there are any impurities in it, okay, if there's any oxygen or any other molecule which has come into it, say it's not so it doesn't remain pure. Okay, so this part, okay, which is made up of or which has consist of something else other than copper as an element, which is a good conductor, this will cause a problem in the circulation of the charge, in circulating the electron across the wire. Okay, so because of this, okay, what will happen is the electric flow or the electron flow will reduce, the rate will reduce, it will become slower. Anything becoming slower due to another particle or due to just merely even the shape of the wire will increase the resistance. That means will slow down the flow of electrons. All right, so that's slowing down. Okay, that's that thing which reduces the speed of the flow of the electrons is nothing but the resistance. So let's write it down. Oh, I forgot power. I will do resistance first and then I'll do power. So it is the property of a substance that opposes the flow of electric current, which reduces the flow. Okay, it is, so resistance does not allow the current to flow optimally. Okay, how much it should. It is measured in, okay, ohms. And what's the symbol of ohms? Something like that. It is a Greek letter. Okay, so what is the what exactly is resistance? So it's greater the resistance, yes, lower the current. We just discussed it. Lower the current, right? It resistance is denoted by the letter R. Okay, in any formula. Okay, so now there's an interesting thing about it. The longer, if the wire is long and thin, so long, that means if I am giving a push, let me draw it here. So if this is my cell, okay, this is a very thin wire. That means a lesser number of of copper elements or copper atoms in the wire. Okay, so if the wire is long and moreover it is thin, okay, the resistance will be high. Resistance will be high if the wire is long and thin. Okay, so how many electrons will it have to pass through to reach the positive terminal, to reach the anode? So if it is long, there can be possibilities of impurities that will stop or slow down the flow of current. Okay, so longer or thinner the wire, higher the resistance, and vice versa. Shorter the wire, a short wire, okay, and moreover, it has more copper atoms. They jump faster, and electricity flows faster. What is the formula for resistance? Formula for resistance is the potential difference, which is denoted by V, upon an electric current. Okay, what does this denote, children? This simply denotes the resistance will be high. If the resistance is high, the current flow will be slow. If the resistance is high, the potential difference will also be high. Got it, children? Okay. Alright, what is power? I forgot this one. Let's do power. Power is nothing but it is the rate of doing the work. What is work? Work is displacement. Okay, displacement or energy transfer. Oh no, not energy transfer. The energy transfer, the energy required to transfer an object, okay, from one place to other. But how fast does this energy transfer? The object gets transferred. So if there is an electron, okay, here's the electron. I'll just make it like a small dot. Okay, how fast will this electron jump across the circuit? Okay, is power, the speed. Okay, so how will we write this down? I think I'll write it on top. Okay, power is the rate. The word rate, children, you know there's going to be a formula, and in that formula, T is going to be down. So in the denominator, the rate of doing work, the rate of displacing something. Okay, so work here. Now, what is the unit of power? It is measured, measured in watt. Watt and not watt. Watt, lovely. Okay, children. So here's one formula. Here's the other formula. So definitions definitely give you a pathway to the formula. When I'm saying these are the formulas, remember the hint is we are going to do numericals as well for this chapter. Let's learn or let's quote down a little a few formulas. Okay, so what's the formula of work? Work is equal to the charge, the electric charge into the potential difference. Okay, all right. It is so. What is Q? We know it is the electric charge. We know V is the voltage. And unit of, what is the unit for work? The unit for work is in SI unit, I would say. SI unit for work is joule. Okay, children? Then comes current. I had made a note over here. Current is equal to Q charge. Okay. Current is equal to the charge upon the time. So rate of the charge, the flow of electric charge across the circuit. That's the current. And current is measured in amperes. So current is measured. So unit is amperes or ampere. Children, did you know that these words, joules, ampere, all these have been derived from or they have come from the last names of the scientists who have come up with the concept of these things. Okay? And then we have power. What is power? Okay, power is equal to work upon time. Power is equal to work or how fast the work is happening. And what is the SI unit? It is watt. There's one more mention on the previous page, which is resistance. So resistance R is equal to potential difference upon the flow of electricity. Yes. So, all right. SI unit, ohms. Yes, children? Alright, so some basic groundwork done for the numericals coming forth. Alright, children? That's all for today. Thank you and God bless you all.